Hi guys, welcome to another code film. This code film is the Callbacks and Asynchronous Services code film. And if this is your first time watching this series, I'll advise you to watch the first episode, which is more of the overview for you to understand the technical direction or the technical point of view of callbacks and asynchronous services. I'll drop the link in the description section so that you can check that out. But in this one, what I really want us to focus on is, or the areas I really want to focus on is blocking and unblocking calls, callback URL, scheduler services. And unfortunately, these concepts or these terms or these words or these phrases, it cuts across all enterprise solutions development most of the time. From the experience that I've had in working with enterprise or writing enterprise solutions, it cuts across and you can't escape it, and that's a sad part. So if you're a developer, welcome. If you're not a developer but probably sometimes you are trying to figure out how all these systems are working, then welcome. So for a technical point of view, there's a good demo for you to probably have more knowledge or more understanding. But if you're a non-technical person, this is also good for you, so that if you are in a meeting and they are throwing a lot of technical jargons, you can now visualize things in your mind and also make some meaningful contributions or even bring better applications out there. Okay, so let's just get started. Okay, so what do I have here? What I have here is a payment application, and because I know a lot of people are now being digitally inclined, payment applications are mostly applications that helps you to make payment or move money from various channels to other people. I don't want to be too technical at all. So we have a number of use cases, and the use cases is the statement, functional requirements, is that tangible thing that you want to see in the application that gives you results. So one use case could be to make mobile money payment from this payment application that's coming from a fintech company, a software company. It could be even a bank, it could be a telco. It's coming from somewhere. It's coming from someone. So if that's payment application, one of the requirements is to be able to make mobile money payment. That use case has to be considered here. And our communication channels for this payment application is mostly going to be gateways, whereby we'll be speaking to other service providers or other networks. And if it's also coming from us, like if this is a CodeFilms payment application, there are also some database records, objects, or entities that we would like to also access once we have a consumer of our application. So just put these things in your mind. We'll be making in this payment application, there are some communications that has to exist, or in other words, the technical term will say maybe the system architecture or the architecture or the infrastructure. All these, I don't want to say all these things involves speaking to gateways and talking to services or objects or records found within the company too. So we have the company zone, and we also have what is known in the company zone. Alright, just put these things in your mind. So with this mental picture that we have of our understanding of what's going on in this payment application, once Stacy launches this application and she's making mobile money payments, several things are occurring once she zones or actions on transferring money to one person. As I've explained, gateway communication, a lot of company zone activities which are occurring here. So now let's go to my IDE and let's start with the blocking and unblocking calls. Just have this in your mind, right? Getting somewhere. Alright, so let's go to the IDE and let's understand blocking and non-blocking calls with the demo. So I have an API that I wrote, and it's just doing some two things. It's getting a list of merchants from a database, all merchants. So I wrote two endpoints. There are two endpoints that exist. One endpoint is synchronous and the other endpoint is asynchronous. The synchronous endpoint is tied to a list. The asynchronous endpoint is tied to a flags object. Just have these things in your mind. So the synchronous bit is merchant sync, and then the asynchronous is just merchant. So I want us to go to our test environment and let's do some test. So someone will say, now what is the blocking and unblocking? Synchronous APIs are mostly referred to the blocking calls, and asynchronous APIs are mostly referred to the non-blocking calls. And synchronous APIs are called blocking because once you zone on those APIs to get a response from the server when you send your request, if you have any process flow or logic or any statement or lines of code below those APIs, it's going to hang. That's what it simply means. So in our test environment here, I have two calls I'm making. The first call here is an asynchronous call. So this is my asynchronous call. And asynchronous calls are non-blocking. And the second call I have here is the synchronous call. And the synchronous calls are blocking. So I'll first demo synchronous, then I'll move to asynchronous. So synchronous calls, let's comment this out. Synchronous calls, as I've explained earlier, are such that if you zone in on those APIs or those services to get a response or to get some data or to do some interaction, it's going to, if you have any lines of code below this call, let's see, I'll say going downstairs. No, just add this. So going downstairs, let's just do this. I'll maybe call a function. I'll say do processing. This is a function that I'll call do processing. Alright, so create method. Let's just create a method. Let's use the ID to do processing, and then let's add some logs here. Look at the info and say, let's see, I am doing processing. I am doing processing. And now inside this block, so many things can occur. Alright, so many things can occur. So I am doing processing. So synchronous, so when you say it's blocking, if we send a request and we don't get a response or something happens, we cannot run do processing because the API service that we've built, just the endpoint that we've tied to, this endpoint is tied to a synchronous. It's synchronous. The endpoint is synchronous. So if I send a request to this using REST template, I'm going to get my response when the request is sent. So I have to wait till I get my response. So do processing will not run till this is done. That's what it means. So let's just run this and see what happens. So I'm going to do something. I'm going to remove my try exception here. I don't want to be too much of a developer. I want to write code like I'm starting. It's not you see something. Okay, so let's run do processing. Let's see what happens now. So I'm in my test environment, and because of my test environment, I'm making a connection to a live server. There's something about testing which says if you are testing something, mostly in a test environment, you don't really make the connection to the live server. That's when you're writing the code. You really want to mock the server and do that work. It's a whole lot of testing stuff. That's not why I'm here. So realize when I try to make the call to the server, it's not up. The server is not up. It's giving me a connection refused. Someone said, how do you know? This is just an exception. You can actually just do a telnet. But in Windows, telnet doesn't work automatically. That's the unfortunate part. So you have to activate it in Windows. So let's go to a local terminal. So let's say telnet, and then the machine is localhost because I've deployed it locally. So it's not recognized. So let's activate telnet for Windows. Let's do telnet. I'm just searching for it. Sometimes you don't have to know so much. And then click OK. We are activating the telnet client. Okay, so whilst that occurs, I just want us to be able to understand what we are trying to derive at, so that we don't get lost when we start zooming in into mixing the blocking and unblocking calls to try and fulfill an action. So I just want us to appreciate this. Okay, so when this is ready, we'll come back and continue. So let's just give it some time. Alright, so our telnet is done. Let's test it and see. Telnet localhost 8080. So it's connecting to 80 localhost. So it has been activated. This could not open to connection failed. So that's how you know if a certain application or service is up. So let's activate it. Let's just run the application, the actual service. Let's run it as a Spring Boot app, and we'll do the telnet again. So if you're a non-technical person, I'm sure by now if they say that the service is not up, you just do a telnet, or let's see if the service is the application is actually up on this port. Oh yeah. So the port is more of the socket for the application. Alright, so what did we do? We started the application. Let's go to our console. Okay, console says Tomcast started on port 8080. Let's do the telnet again. Let's see what we get. Voila, this time around the telnet didn't hang. It zooms in, so we can safely say that connection to host has been lost, has been closed, so a connection has been established. Let's do that again. So it means it's connected. It's not showing connected, but at least we are getting some response, so it's better. It's better. Alright, so yeah, so it's actually logging against. Yeah, don't worry. So it's working. So you can just do a telnet. If anything happens, just do a telnet. Let me see if the bash can also help us. Can do the telnet in bash. I'm not too sure about that. I know Linux box can help you, but the bash, does bash even know telnet? Because the bash has a Unix environment behind it, so okay, let's close this. System has hanged. Let's close it. Let's run it again. let's do a telnet localhost 8080. okay, this one too is working as long as we are not seeing. Yeah, so the bash is also working, so the telnet is fine. Right, now let's just go back to what we actually want to do. So our service is up, that's what's important to us. Let's go back to our test environment and let's go and figure out what needs to be done. Test. Let's run this again. So we want to get a list of merchants from our database. That's what we want to do. Because you realize that this time around we don't get an error in our JUnit panel, our stack trace here. All we just see is that it's okay. Then let's go to our console, let's see the logs. So we can actually see that what we've logged is being printed. So it says that I'm going downstairs and I'm doing processing. So I'm doing processing. We've been able to call the method called I'm doing processing, and we've been able to get our merchant list from the database. That's very good. Okay, so this is for the blocking. So you see what the blocking does. So let's just do this. Let's actually let me mess up this endpoint I want to call, and let me call a endpoint that is not on our service or is not within our API. So we are calling a full endpoint. It doesn't exist or it can't be found in our controllers, the list of controllers that we've built. If I go to show message, come here, merchants, and I come here, none of the endpoint here has full. So I'm actually trying to just do this to test something. So let's go back to application. Alright, then let's run this full and let's see what happens. So because it's blocking, remember the key concept here is that we won't be able to go to do processing, because this, once we don't get a response, when we send a request, anything here won't continue, it won't work if there's an error or anything of that sort, because it's blocking and it's synchronous. Just accept it and let's just see what happens. So in this case I'll run it first. Let's run it first. Run on server, run JUnit test, sorry, and let's witness what happens. Okay, so realize that our stack trace has actually seen that there's an error, and this time around let's pop this out. Okay, this time around it's complaining of 404 and it's saying that the path we are seeing cannot be found, and because of that realize that we couldn't go to do processing. We start from at inside test hello world. If we do a search find, let's find. Okay, to find within this context, let's find within the source code. That's what I want to do. So search, let's copy this. I copied it, it's not copied. Let's copy it first and let's search within the source code. Search. Alright, so it is there, it is copied by clipboard. Let's just search. Okay, so it's not in the workspace. The search was too generic. Let's search within the file. Sorry. File search. I saw inside test hello world. That's what I saw. Test hello world. This workspace scope. Let's search again. Oh, my search is not giving what I want. Wait, let's do this wall. If not, you can just do Control F here and put it there and search it to find it. I was trying to do more of a generic search, but that should also work. But if not, just do Control F in the source code and you can search. Let's go back to search. Derive, workspace, tag search, Java search. I'm not searching for any Java package, so it's more of file search. Search a file. If let's see what we get. Voila! So it's working now. So we know where we are. Okay. So let's okay. So it's not working. You can say it's not working. The reason is that it is not. It has thrown an exception. The exception is what is happening in the stack trace here and our trace here. So it didn't get to do processing because it's blocking. Alright, it's blocking. Okay. So we're okay with this. Now let's go to the non-blocking side and continue. Let's do the same thing for non-blocking. So I'll comment this out and I'll just copy the same lines of code here and I'll go and activate the non-blocking bit. So our non-blocking says that we don't care. Non-blocking simply means that when I send my request, when my response is ready to be communicated to me. So if I have any logic or any process flow, any statement, any processing operation that has to be done downstairs, it will be performed because it's asynchronous and it's non-blocking. So when the response comes, then we are okay. You understand? It doesn't prevent any other process flow from not being executed. So first we'll run it. Let's run it with an error before. So let's go to our application controllers and let's see what is valid. The valid is merchants. So let's just change it a little bit and test our sessions. Alright, so let's add another foo here. We know that foo doesn't exist and we are saying that fine is non-blocking, so whatever be the case, do processing should work because the API or service we are consuming is a non-blocking API, and we've explained how it's non-blocking because of the flags objects. I won't go too much into this. It's a different programming world, just for us to understand non-blocking and blocking. So let's run this and see what our output will be. We realize that in the blocking, this is the blocking results. We didn't see do processing at all. The logs for do processing didn't show, and I'm doing processing didn't show. It didn't. Here is going to show. So let's run it. So we'll search for it. Don't worry. There's an error. It's non-blocking. So it will be the call will be made to go and do the call, and then still we'll go to do processing. Okay, so it has finished everything. Is it this one? The blocking didn't crash our application, but let's just continue. Fine, that's good. I like what I'm seeing here. Oh, this is so beautiful. You see, even though we explained that it's non-blocking, you see this time we are able to go to I'm doing processing, and yeah, there are some exception being thrown because yep, it's coming from the wrong directory provider, but you know it's neatly handled by the non-blocking API or the asynchronous API framework we are using. So we still are able to reach I'm doing processing. It doesn't stop us from going downstairs, as the blocking stopped us from going downstairs. So that's the beauty of the non-blocking. So now I'm sure now you've clearly understood the difference between blocking and non-blocking. Okay, so that's just it about blocking and non-blocking, or synchronous and asynchronous calls. If you are still in doubt, let's do the non-blocking again, the blocking again, for you to see and compare the two results. So this is the results for I'm doing processing. This is the blocking results, the non-blocking results, or the asynchronous results. It's called Notepad. So this is the first result we have. Let's save as non-blocking. There are a lot of doubting Thomas. Sometimes in computers, what you see is what you get. So when you see something, you really appreciate it more. Non-blocking. Right. And let's activate the blocking bit again. Let's run it. Yeah, so this one you actually see is crashing our application. The framework is not handling it properly. So let's just go back and see. This is the blocking. We don't even get to doing processing. So this is the blocking results too. So let's save the two. It's just for the doubting Thomases. Alright, so save as, I'll say blocking. Okay, so good. So if I do a search now, I have the non-blocking. This is a non-blocking, and I have the blocking too. Alright, so can open the file and just compare the results. So blocking is here, and let's open non-blocking. Sorry, non-blocking and blocking. So we compare the two results and see for your own eyes. Here we have I am doing processing. Here if you search for I am doing processing, we don't see it. Okay, but if we also search here too, just cannot find. Okay, I am doing processing. So let's go up. Fine, so you can see it because we're going down. Yeah, it doesn't exist. Please, if it's not there, it's not there. If you go up to, it's not there. Yeah, so it cannot be found. Alright, so that's just it for blocking and non-blocking. So someone will say, let's go back to the source code. So you realize that if you have a service that we are building, or an API, you know, that where I'm trying to get to where we are going to now, and I have all these two in play. Now let's make them work. Let's see how it works, and both of them are all in play now. Alright, so both of them are all going to see I'm going downstairs, but I'm going downstairs from a non-blocking, going from non-blocking stairs. I'm going from a non-blocking stairs, and then here too I'm going from a blocking stairs. So we're now calling do processing. So let's just do this. Let's pass a string to it, and you see this is from I'll just say this from non-blocking, and I'll pass another string here just to say this is from blocking. Let's make it capital. Isn't this thing interesting? Like, and then later, okay, there's a gradual step. Then let's do the blocking. Let's use the ID to do the work of adding the parameter. Okay, it's in change method, so no, we won't change. Let's just add parameter. There's this one way. The other way to is to do refactoring. Then change method signature. And instead of we say add a type, and then we just say string, and then the name of the variable will be call type, and then it's null. That null is fine. So we were just doing some refactoring. Then later on, let's go to the implementation. And let's say I'm doing processing, then let's add this from, let's say I'm doing processing, and let's just do this call type dot to uppercase. It's already in uppercase, but let's just have this here. Right, so that's it. So don't let us put it at the back. Let's do it in front so that we see it first. Okay. Alright, so we are fine now. So we have all the two in play now. So we have all the two in play. How is this going to behave? And the behavior still remains the same. You understand? We only get a response from asynchronous API when it is ready. We hit a request, and when the response is ready, it comes to us. It doesn't block our flow. You understand? So it's like this is happening in the background, and other processes can still take place. That's how basically it's working, like a thread. You understand? I don't go too much into those things. It's just overviews. And then this one too is it's like a single, it's blocked. It's a thread, but it's just, don't go there. But just for you to understand that once you send a request, we need a response. So if we don't have our response, we can't go downstairs. You understand? We stay upstairs. That's what it just means. So but this one, we can even go and hide ourselves somewhere, and then when our response is ready, we go and process it. So we can actually handle other process flow. So let's run this and see what happens. So we have all the two in play. This line of code can even be executed before we get our data. That's fine. Then later on we go to the blocking side. So let's just run it. And unit test. Okay. Okay, so we have no errors. Let's go and see our logs. Okay, it says connection was closed prima. Don't worry, that's fine. We just run it again. So what we have here is our results. Our results is saying non-blocking, going from non-blocking staircase. See, we are trying to get the merchant asynchronous list. I hope you guys are following me here. I want to open it side by side. Okay. So we start from this line of code. Let's go straight down. So I'm going to get merchant asynchronous list. We are here now. Then we don't see this, but it doesn't stop us from going to do what? I'm doing processing non-blocking. You understand? So because this is being executed non-blocking, and I'm doing processing. This is a process that is being executed. And it says I'm going downstairs from non-blocking side, but actually we are not seeing a response from the asynchronous API. Then we go to the synchronous bit. Our synchronous bit actually executes everything and gives us a response. Then later on, it seems our response is ready from our asynchronous API, but because of the nature of it, it's telling us that a connection was prematurely closed before the response. That has to do with the client setup, certain default values that have been set for the client. But let's run it again and see what happens. It could also be connectivity, so many other things. So let's just run it again. So we do see that it doesn't stop us. We still be able to go to doing processing. That's what the whole understanding is about. Let's hope that this time we get a response. It won't be closed prematurely. And it could also be that because two services are trying to consume the service, so one is consuming another. So what we'll do is I will actually close. Let's off one of the services. Let's off the live server. Let's start it again. Then we'll look at the results. Let's stop this. Let's run it again. It could also be that the database, once one call goes, trying to get another call going is also affecting our the time or latency for the data to come out. Is so many factors. Alright, so let's just run it again. Let's run the test again. If you don't get a response, don't worry. At least we understand the process flow. That's what's important. Oh, beautiful. This time I'll draw the response for both. Voila. That's good. So it was actually because it's like two calls are being made, or two transactions, or two separate transactions are hitting our database and one is not yet coming. So it's a whole lot of factors, connection pulling, and maybe something of that sort. So what's important is that it doesn't stop non-blocking. I'm doing processing from running. It runs fine. This fine, that's the asynchronous bit. Synchronous bit runs fine, and later on we get our response from our asynchronous API. And how do we know that is the response? Because there's an emit that I'm using to distinguish it. If the emit is not fine, you can even make it asynchronous emit, and say async emitting. Let's run it again. So this is the first area that I really wanted us to focus on: non-blocking and blocking, and we've seen it in play. So at least now you appreciate it. So let's just wait for the results for this, then we'll proceed to the other areas. So all this, and what's important is that all these things are happening right inside your application. So this time we're getting connections closed prematurely. Yeah, so let's just stop this and run it again. Sorry. And so all this is happening. If you have an application that you are using, payment application, so now if you just apply it in a real world scenario, all this is happening behind the scenes in your payment application and other applications, whatever you have. So now you know how to. What's important is that you understand it, so you should be able to see it in real time now, in real life. So if, for instance, I go to I have some variables that I need to do some performance testing. Not performance testing per se, but I need to do some verifications and other operations. So final, so you can see async emitting. So that's okay. So we are okay now. I'm non-block. I'm doing processing. We leave this, then our response comes later on, and we are all seeing it. That's the beauty. All right, thank you. So now let's go to our diagram, lectures. So you see that if you have this in a payment application, one use case making payment, another use case money transfers, a whole lot of things happening in your payment application. Some services may be asynchronous calls, some services may be asynchronous and synchronous. Some services will be asynchronous, some services will be asynchronous. So it's not all the time that all the services will be synchronous. Some will be sync and some will be async. Some will be blocking, some will be non-blocking. So based on the use case you have to see whether you're making some gateway communications will be synchronous or asynchronous calls, or even some companies' own communications will be synchronous or asynchronous calls. So that's the blocking and non-blocking calls in our focus is a payment application. The last gray area I want us to also look at is, for instance, if I have, let's have this method here. I have a method that does verification, or I have private do void do verification, and in doing verification I pass most of the common personal data object that people collect, or companies collect, or entities collect, or agents collect for KYC or know your customer, or for verification purposes. It's mostly phone number. You also have the driver's license number, and then sometimes your passport. So string. Okay, so if this is what we are doing in doing verification of a person or a customer or whoever the focus is on, if I have to pass all these to, let's say I have 3 APIs. I have an API that does phone number verification API to confirm that the number has been given that has been shared with me by a customer exists. I'll call a phone number verification API, and that phone number verification API will have, of the 3 telcos that I know of because of my location, Ghana, I'll mostly see that I want to verify the number across the 3 telcos platform: MTN, Airtel, Tigo, or Vodafone. You understand? And in doing that, I may want to make this an asynchronous call. So I want to make this an async operation. Async operation. And the reason I want to make async is that because I want to speak to MTN. When MTN is ready with the response, I get it. So it doesn't block me also speaking to Tigo. It doesn't block me speaking to Vodafone. So this is a phone number verification API probably that may exist in the company. And then, so if we take all this, someone in the company would have created this phone number verification API, or for all the telcos. And this is an API that has been built by a developer in the company. And then all these methods, all these checks has to be done inside. So that developer could decide to make the API what? Async, so it doesn't hang any other process. So that's where the developer I would say ingenuity comes inside. So whether it should be async or asynchronous or not, but this is what one API you are calling. And you also have the driver's license. For the driver's license too, you could be calling DVL's maybe verification API, and down to you can make it async. So when DVLA is ready with the response, you make it async. Just put that in your mind. And then the last one to be to speak to passport office verification API. Okay, and then the reason we are doing this one too, so we can make all this what? Async. So what we are saying is that the end results of this and this, we'll say probably we can confidently have an agreement with this person. That's why, because we've had all the response, if all this is positive, so this is happening in the background, this is working in the background, and all this one is also running. So this one will bring the results later. So maybe it could be that the passport will come first, passport verification response will come first, response passport DVLA, and then phone number. So if all is true, then we can confidently work with this person. This person has successfully been what? Successfully KYC'd. You understand? So that's just one way of seeing how it works, not just by instant blocking and unblocking, but asynchronous and async. So there's the beauty of it. Alright, so if you have this in your payment application, it could be even certain details or entries that you pass now or have all this, or if it's just probably a single identity record that you have to pass for this to occur in the identity API you are calling, probably the services you are calling or work as asynchronously. If you pick something like the Ghana card, let's say do verification, if I'm the developer for the do Ghana card verification, and I pass my Ghana card, and I pass my Ghana card number, it's going to make all these calls. So I can actually call do verification inside here. So probably this is what the Ghana card service actually does. Void. It takes the Ghana card and it goes and search for your phone number, that, and all those communications in the gateway. So all that could be happening when you probably present your Ghana card to the company to know that the one come to make payment. So all that communication could be happening, and it's all inside this payment application. It's all happening inside the payment application. So I hope we are okay now with the first gray area, which is the synchronous and asynchronous bit, and with, in other words, blocking and non-blocking. Alright, so that's it for the first one, blocking and non-blocking. So we're going to come back and look at the remaining topics we have, which is the callback URL and the scheduler services.